Hey guys, Wintermute here, and today we'll be making the Trebuchet, which everyone knows is the superior siege engine. Now, if you've ever wanted to work with rigid body physics in Blender and make simulations like this is the tutorial for you. So we're going to be using a couple of different techniques in order to animate this, which will require no manual keyframing, and let us do this fairly quickly using only a couple of simple tools. So, to start off, we're going to make the Trebuchet model. Set the render engine to Eevee, and I'm going to split this tab so I can open up a reference image. Now, I took a look at how a Trebuchet actually works in order to record this tutorial, and you might want to do that too, just to get a sense of what the mechanics of this thing are. I found this reference image on Wikipedia at the bottom right. You can use any you want, but I'm just going to be basing my model off of this. Also, I'm going to be going for a simplified sort of low poly look because really the point of this tutorial is not to make a photorealistic trebuchet. I just want to explore the use of rigid body physics with Blender. Alright, so this is the base platform, and what you're going to see throughout this is that I'm going to make pretty much the whole body of this trebuchet out of primitive cubes and elongated rectangular prisms. So for these, I'm going to have sort of a triangular arrangement of support struts, and I'm going to make sure the origin of these is at the bottom, just so it's a bit easier to rotate to fit what I want this to look like. So I also don't really care too much about the dimensions here. It's not too important, I think, and we're going for a stylized look anyways, so don't worry too much. If you want, you could probably look up the actual physical characteristics, including the height and width and general dimensions of these things, as well as the relative weight of the counterweight to the throwing arm, but it probably doesn't matter too much. Alright, so here's the central thing. I don't know what this is called. This is the piece on which we have an axis mounted, or an axle, I guess. I'm going to make those angled struts a bit smaller, and I'm going to add a central section here, just to join all of this together. I'm basing it off of the reference image I have in the lower right, but you really can base it off of whatever you want. There are lots of different designs for trebuchets, and you don't have to pick this one, but I'm just going for this look right now. If you want to actually make this preview look a bit better, you can go into the viewport overlays and turn on, viewport shading, and turn on both the cavity option and the shadow. Sorry about the background noise, by the way. I unfortunately do not have soundproofing. Alright, so you can duplicate these struts and put them side by side. Just slide them over on the x-axis so that they're closer together, and we're going to suspend an axle between them. So in order to make that axle, I guess you could use a cylinder if you wanted. We're not actually going to be simulating rotation around that axis. We're going to be using sort of an invisible pin. Okay, so I'm going to center the origin of this prism, and I'm going to shrink it down a bit. Once it's positioned correctly, I'm going to just scale it on the axis perpendicular to the main one, and I'm going to rotate it 45 degrees. Now you don't have to do this, really this is just a stylistic choice, but I like this sort of diamond shape as opposed to a flatter prism. So make sure you just give it a bit of an offset. Alright, so now for the throwing arm. So one important thing you want to do here is that you want to make sure that the origin of the throwing arm which is the orange dot in the middle, is situated on the hinge or on the pin. So in order to edit the scale, we're going to do this in edit mode instead of just dragging it around in object mode so that the origin stays in the center. We can also scale this in, and we can give it a bit of detail by extruding it inwards and making it look like there's sort of a cut in the middle, like you've stuck two different pieces of wood together because the whole thing is too long to be made out of a single slat or a single strut. Just extrude it outwards, make the end a little bit smaller, and what we want to do is make it so that the length of this, once it's been tilted down as if influenced by gravity, we want to make it so that that just about hits the end of the platform. So you can just test it a bit. Of course, there are other ways to fit it more precisely, but again, not too important. That looks good enough. Alright, so this is the main structure. Now if we want to add physics, first we need to set up a system of rigid bodies. And we need to add our counterweight, so let's do that first. So again, we'll keep it simple, and we're just going to use a simple cube. Don't worry about the volume. So Blender doesn't calculate the volumes of, or the masses of things based on volume. Like there's no density calculation going on here. It's just, mass is something that you'll set later in the rigid body settings. So I'm going to experiment with a couple of designs for this counterweight. I'm thinking that this is sort of pinched. The counterweight sort of pinches the throwing arm, and I'm going to bridge it at the top as if this was a sort of a chain on a hook, but you don't really need to do that. Instead, I'm going to convert this to something a bit simpler later. But if you like this design, you can go ahead with it. This is sort of like a padlock shape, I guess. And this is pretty similar to what the reference image shows. Alright, so I'm going to extrude out a hook on this. Again, I'm probably going to remove this in the final version because it might not look very physically accurate, and it'll cause some weird issues with the bending, but that's alright. Okay, cool. So this looks a little bit like a cannon with a counterweight at the end. So let's give it some physics. So let's add this rigid body to the counterweight, the rotated hinge thing, and the throwing arm. Then you can see that they just fall and they don't really interact like you'd expect. So let's make an empty here. We want to pin everything in place, and we're going to use rigid body constraints to do that. So we have this empty here, and we choose the one that shows you the direction of the axes because we want to fix the z-axis as parallel to the axis of rotation. And then we can use the objects to pin it, which is pretty cool. Now, I'm not really sure why this weird sort of thing happens, where it rotates so that the bottom end faces down. Like you'd assume that the longer end would end up on the ground, but there's a bit of weird physics there. Alright, so we can duplicate that hinge and move it to the intersection of the counterweight and the throwing arm, and then we can assign both of those objects to the pin. And now you can see that they both swing together like you'd imagine a trebuchet does, and this is the basic mechanic of it. You don't want to disable the collisions. If you want to actually have these things interlocking, you'd have to set the collision shape to mesh. Otherwise, the convex hull will just give you sort of the outside shape, but it's not going to give you like any holes in an object or anything like that. And turn on the margin a bit, and you'll see what happens. So we have these two interlocking pieces, and they'll stick together, but this doesn't look too physically realistic. I think stylistically I'd like the counterweight to swing sort of like a pendulum from the bottom of this thing. So locking it in place with this hook and loop thing is probably not a good idea. So instead we're going to change that in a moment. Also, we want to alter the weight of the counterweight. Again, you can look up some physical tables for this, I'm sure, but in this case, we're just going to use whatever looks reasonable. Now, I like to set, after a bit of experimentation, I thought having the counterweight as having about 10 times as much mass as the throwing arm seems to work for me. Okay, so now I'm just going to correct the design, and I'm going to go with a more consistent pin design. So I'll remove the pieces here that I created before, because we don't really need them. Though, again, if you like it, you can keep it as it is. Alright, so I'm going to move this pin thing back. I duplicated it, and you know that we want to join this with the counterweight, so I'm actually just going to join the two objects physically with Ctrl-J so they move together, and they're actually part of the same object. So in this case, that hinge thing is not actually going to rotate, but it's going to be too small to see anyway, so it doesn't really matter. Okay, and I'm just going to square off the top now. Again, physically, I don't think this is possible, but you probably don't need to worry about physical plausibility at this point. That's not really too essential. And here we have the actual mechanism working. That's pretty cool. Now that we have our collisions disabled, it doesn't actually hook, and the counterweight swings like a pendulum from the bottom of the throwing arm, which is exactly what we want. Now make sure we have both the hinges in the right place. So it seems that the empties, they don't actually have to move with the objects they're pinning together, which is a bit weird, but I don't know, Blender has its quirks. So I'm going to rotate this into a more standard position, not completely flat, but rather with the counterweight as high as possible to have as much potential energy to whip around the projectile. Alright, and I'm going to add a bit of a sort of hook thing at the end, just because I think that would look a bit more realistic. I think it looks a bit better. So I'm going to make a couple of loop cuts, and I'm just going to scale in this piece. So now we can imagine we can toss a rope around there and it will whip it around. Alright, now for the actual rope, because what we have right now is a weird vertical pendulum. So the easiest way to make a rope in this case is by using a plane, and we're just going to scale it up. Now if we apply a cloth physics to this, it's not going to do anything because it doesn't have enough geometry, so let's loop cut it like 50 times. And the more times you do it, the higher the resolution, but at some point you won't be able to see it because, again, this rope is going to be moving extremely fast. Also, we want to sort of hook it to the actual lever arm because it's not going to move if we don't. So let's give it a sort of realistic fall off and use proportional editing. Hit O, by the way, or go to the bottom center. And you'll see that sort of inverted V shape. Click on that, change it to sharp. Make sure that you have not like a straight vertical line connecting the rope. Okay, and let's add a vertex group now. So we can call this pin because that's what it's going to do. And don't be a dummy like me and actually assign it to the vertices we're trying to pin. Okay, and I'll do that in a moment. So turn off proportional editing by hitting O again. And then we're going to make this sling part. Now, unfortunately, I don't actually have a projectile to go along with this, so we won't be able to see that. But this will be good enough for now. So in order to subdivide this, we can right-click and hit the subdivide option, and we can change the resolution. All right. Now we can add a cloth modifier, or a cloth simulation, and you'll see this doesn't do anything because the bottom plate doesn't have a collision, so we're going to apply a collision component to it. And that seems to work reasonably well, except that the actual rope isn't attached. So what we want to do is we're going to go under the Shape tab, and under Pin Group, we'll select our pin vertex group that we just made. And it's still not going to move because we need to parent it, so hit Control P with the lever arm as the active object and connect them. Now again, as I said, I managed to not actually assign the pin despite having made it, so I'm going to realize that in a moment. You don't need to move the origin to the pin location, although it might be a good idea to do so, just so it's a bit more clear what's going on. But you'll see that happens if you don't actually assign the pin. So right now, that there's nothing that's actually being pinned by that pin group because that pin group is empty. So let's fix that. So what you want to do is maybe go into wireframe mode, select the vertices at the end. I'm going to make an extra face there just because, and you actually have to click that assign button with the pin vertex group. And there you go. And that's the pendulum, or I guess the trebuchet with a sling attached, which is what we're looking for. Now you're going to see that it actually clips through the throwing arm, and also all of the other structures. And this is because rigid bodies don't actually block cloth objects, so you need to give it a separate collision component, like we did for the bottom plate. So we can go back into the physics tab, and we can apply a collision component to it. Also, another thing to note is that because Blender's physics don't work continuously and calculate things kind of discretely, if things are working really, or if things are moving really fast, they might still clip. But that's okay, because it'll be moving too fast to see anyways. Alright, now to stylizing it. This is going to be up to you. I don't really want to make too long of a tutorial here, so I'm not going to go over all of the stylistic components to this. Just give it a nice material, maybe turn on freestyle, and I suggest you render this in Eevee because I don't think Cycles has any particular advantages here. And the important thing is that you have to bake the rigid body, so you want to go under Rigid Body World, Cache, and then Bake All Dynamics. And you'll note that if you do this, you won't be able to change the physics animation unless you delete all bakes and then bake it again. But if you do not bake it, when you render the animation, it will not actually move. The physics won't be calculated. So you want to make sure to bake all the dynamics before doing the final render of the animation. And there we go. I thought this was a pretty cool project to make. It's pretty simple and is a great starting point if you want to play with Blender's physics engine. I found out a lot of stuff here, and it seems to be really, really powerful. So there's definitely more that I'd look into in the future, and if you're interested, be sure to leave a comment about what sort of siege engines you might want to see. I'm thinking of a ballista maybe, or some sort of catapult, even though those are quite inferior. Alright, and here's another trebuchet thing I made a while before while I was prototyping this tutorial. This swings a bit more wildly because of the length of everything being a bit different. But yeah, I think these are pretty satisfying to watch, so if you want to render a longer animation, go for it. So yeah, that's the tutorial. I hope you enjoyed it. Be sure to like and subscribe, and I'll see you next time.